The National Electrical Code, NEC, does not specifically prohibit the use of galvanized steel boxes for electrical installations near pools. However, there are potential concerns. Firstly, corrosion. Galvanized steel can corrode, especially outdoors where it's exposed to moisture and chemicals. Over time, corrosion can damage the box and reduce its integrity. Secondly, bonding. Galvanized steel isn't a great electrical conductor. This can make proper bonding between the electrical system and the pool equipment difficult. Bonding is crucial for preventing electrical shock. Thirdly, conduit compatibility. Galvanized steel boxes aren't compatible with every type of conduit, especially non-metallic conduit. This can cause installation and compatibility issues. Local codes may have specific requirements or restrictions even if the NEC doesn't prohibit galvanized steel boxes for pool installations. Always check with the local authority having jurisdiction for specific requirements. The inspector may have concerns about corrosion or bonding, especially given the proximity to the pool and the GFCI protection in place. It's recommended you contact the AHA to clarify their specific reasons for requiring replacement. If the AHA requires the replacement of the boxes, it's generally the responsibility of the contractor or electrician to make the necessary changes. Consider the potential issues even though the NEC may not explicitly prohibit it. Think about the long-term effects of corrosion on the galvanized steel box in an outdoor environment where it is exposed to moisture and pool chemicals. Over time, this corrosion can weaken the box, potentially compromising its structural integrity and ability to protect the electrical components within. The compromised box could lead to safety hazards, such as exposed wiring or electrical faults. Proper bonding is essential for electrical safety around pools. It creates a low impedance path for fault currents, allowing the GFCI breaker to quickly trip and de-energize the circuit in the event of a ground fault. Galvanized steel's poor conductivity can hinder effective bonding, increasing the risk of electrical shock. Make sure the bonding methods you are using are sufficient. Incompatibility between galvanized steel boxes and non-metallic conduit can create challenges during installation. Non-metallic conduit is often used in pool areas due to its resistance to corrosion. Connecting it to a galvanized steel box may require special fittings or adapters, which can add complexity and potential points of failure to the system. The local authority having jurisdiction has the final say. They may have additional requirements beyond the NEC to address specific safety concerns in the area. These local rules might be based on environmental factors, past incidents, or unique characteristics of the local electrical infrastructure. You must be aware of and compliant with all applicable local codes and ordinances. Corrosion can lead to a gradual degradation of the galvanized coating, eventually exposing the underlying steel to the elements. This can accelerate the corrosion process and further weaken the box. The presence of pool chemicals, such as chlorine, can exacerbate corrosion of metallic components. Even small amounts of chemical residue can accelerate the breakdown of galvanized steel. Proper bonding ensures that all metallic parts of the pool and electrical system are electrically connected. This minimizes voltage differences and reduces the risk of electric shock. Effective bonding requires reliable connections with low resistance. Galvanized steel's properties can make it difficult to achieve and maintain these low resistance connections. Using dissimilar metals, such as galvanized steel boxes with copper conductors, can also contribute to corrosion over time through galvanic action. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as water. The less noble metal, in this case galvanized steel, will corrode more rapidly. When using non-metallic conduit, it is important to use appropriate fittings and connectors that are specifically designed for use with both the conduit and the box. These fittings should provide a secure and watertight connection to prevent moisture from entering the electrical system. The local AHA may require specific types of boxes or installation methods to be used in pool areas to ensure compliance with local codes and regulations. It is important to contact the AHA early in the project planning process to determine any specific requirements. It is advisable to use corrosion-resistant materials such as stainless steel or PVC for electrical boxes and conduits in pool areas. These materials are less susceptible to corrosion and can provide a longer service life. Ensure that all electrical components used in the pool area are properly grounded in accordance with the NEC and local codes. Grounding provides a path for fault currents to flow back to the source, helping to trip the GFCI breaker and prevent electrical shock. GFCI breakers provide additional protection against electric shock by monitoring the current flowing in a circuit and tripping if there is an imbalance, indicating a ground fault. Regularly inspect electrical boxes and conduits in pool areas for signs of corrosion or damage. Repair or replace any damaged components immediately to prevent potential safety hazards. Keep detailed records of all electrical work performed in the pool area, including permits, inspections, and any modifications made to the system. This documentation can be helpful for future maintenance and troubleshooting. Consider the long-term cost of using galvanized steel boxes in a pool area. While they may be less expensive initially, the potential for corrosion and the need for more frequent replacements can outweigh the initial savings. Properly installed and maintained electrical systems are essential for the safety of pool users. Take the time to ensure that all electrical work is performed by qualified professionals and that it complies with all applicable codes and regulations. Consider using a junction box made of a non-metallic material like fiberglass or PVC. These materials are resistant to corrosion and are ideal for use in damp or wet locations. Ensure that the junction box is properly sized for the number of conductors and devices that will be installed in it. Overcrowding a junction box can lead to overheating and other problems. When making connections inside the junction box, use connectors that are listed for use with the type of conductor being used. For example, use copper connectors for copper conductors and aluminum connectors for aluminum conductors. All splices and terminations inside the junction box must be properly insulated. Use electrical tape, wire connectors, or other approved methods to ensure that the conductors are properly insulated and protected. Secure the junction box to a stable surface using screws, bolts, or other appropriate fasteners. The box should be mounted in a location where it is protected from physical damage and where it is easily accessible for maintenance. Label the junction box with a clear and concise description of its contents. This will help electricians and other personnel to quickly identify the box and its purpose. Periodically inspect the junction box for signs of damage, corrosion, or other problems. If any problems are found, repair or replace the box as necessary. Also, ensure that all grounding and bonding connections are properly made and tightened. This is critical for preventing electrical shock hazards. Use appropriate fittings to ensure a watertight seal. Remember to consult the National Electrical Code and local codes for specific requirements related to electrical installations near swimming pools. Compliance with these codes is essential for ensuring the safety of pool users. It's always better to err on the side of caution when it comes to electrical safety, especially around water. If you have any doubts about the proper installation or maintenance of electrical equipment, consult a qualified electrician. Furthermore, consider the type of pool. Is it saltwater or freshwater? Saltwater pools can be particularly corrosive to certain metals. Even if the NEC doesn't explicitly forbid galvanized steel, the environment might make it a poor choice. What type of chemicals are used to treat the pool water? Some chemicals are more corrosive than others. Consider whether the galvanized steel can withstand these chemicals. The distance from the pool is also a factor. Even at 18 feet, moisture and chemicals can still reach the electrical box. Consider the prevailing wind direction and how it might carry moisture and chemicals towards the box. Regular maintenance is key. Even if galvanized steel is used, regular inspections and maintenance can help to identify and address any corrosion issues before they become major problems. Keep detailed records of all inspections and maintenance. This can help to track the condition of the electrical system and identify any trends. Consider the long-term costs. While galvanized steel might be cheaper initially, the cost of replacing it due to corrosion could be higher in the long run. It may be more cost-effective to use a more durable material like stainless steel or PVC. Is the electrical box exposed to direct sunlight? UV radiation can degrade some materials over time. Consider whether the galvanized steel is protected from direct sunlight. What is the temperature range in the area? Extreme temperatures can also affect the performance of electrical components. Consider whether the galvanized steel can withstand the temperature fluctuations. In addition to corrosion, also consider the possibility of physical damage to the electrical box. Is it located in an area where it could be struck by objects or damaged by vandalism? If so, consider using a more robust enclosure. Ensure that the electrical box is properly sealed to prevent the ingress of moisture and insects. Use a sealant that is compatible with the materials being used. If the electrical box is located in a high-traffic area, consider installing a barrier to protect it from accidental damage. Make sure that the barrier does not obstruct access to the box for maintenance purposes. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment, such as gloves and eye protection. Energize the circuit before working on any electrical components. If you are not qualified to work on electrical systems, hire a qualified electrician. Staying updated on the latest codes and regulations is vital. Electrical codes are constantly evolving to address new technologies and safety concerns. Make sure that you are familiar with the latest requirements. Participate in continuing education courses to stay up to date on electrical codes and best practices. Consider using a surge protector to protect electrical equipment from voltage spikes. Surges can damage sensitive electronic components. Regularly test GFCI breakers to ensure that they are functioning properly. GFCI breakers should be tested monthly. Install warning signs to remind people about the dangers of electricity near the pool. Signs should be placed in prominent locations where they are easily visible. Educate pool users about electrical safety. Teach them about the dangers of electricity and how to avoid electrical hazards. In summary, while the NEC does not outright ban galvanized steel boxes near pools, the potential for corrosion, challenges with bonding, conduit compatibility issues, and the possibility of stricter local codes necessitate a careful evaluation of the specific installation environment. Consulting with the AHA and considering the long-term costs and safety implications of using galvanized steel are crucial steps in ensuring a safe and compliant electrical system around a pool. Also remember to examine the type of grounding electrode system being used in the premise. The grounding electrode system is used to connect the electrical system to the earth. This helps to protect against electrical shock and damage to equipment. There are several types of grounding electrode systems, including ground rods, ground plates, and concrete encased electrodes. The type of grounding electrode system that is used will depend on the soil conditions and the local codes. Ensure that the grounding electrode system is properly installed and maintained. This is critical for protecting against electrical shock and damage to equipment. Inspect the grounding electrode system regularly for signs of corrosion or damage. Repair or replace any damaged components as necessary. Check the resistance of the grounding electrode system to ensure that it is within acceptable limits. The resistance should be low enough to provide a good path for fault currents to flow back to the source. If the resistance is too high, the grounding electrode system may not be effective in protecting against electrical shock. Using a ground rod driven into the earth, be sure it is installed deep enough. The depth will depend on soil conditions. The AHA may require the use of multiple ground rods to reduce the resistance of the grounding electrode system. When connecting to the grounding electrode system, use appropriate connectors that are listed for use with the type of conductor being used. The connectors should be properly tightened to ensure a good electrical connection. Protect the grounding electrode system from physical damage. The grounding electrode system should be located in a place where it is protected from being hit by vehicles or other objects. If the grounding electrode system is located in a high-traffic area, consider installing a barrier to protect it from accidental damage. Grounding is critical for electrical safety. Proper grounding can help to prevent electrical shock and damage to equipment. It is important to understand the principles of grounding and to ensure that the grounding system is properly installed and maintained.